All right, we're going to go ahead and solve 3x squared minus 12x minus 15 equals 0. And we're going to try to see if we can solve it algebraically 3 different ways. So let's go ahead and try factoring. So to factor, it has to equal 0, which it does. And then we look for a GCF, something that goes into 3, negative 12, and negative 15. So I know that 3 can go into all of these. So I'm going to put the GCF in the front. I'm going to factor it out. So 3 times x squared is 3x squared. And then 3 times negative 4x is negative 12x. And then 3 times negative 5 is negative 15. Okay, and then to factor, we ask ourselves how many terms. There's 1, 2, 3. So when there's 3 terms, we can use the AC method. So since there is no number here, we know it's a 1. So we do 1 times negative 5. So that's negative 5. So we have to find what multiplies to negative 5, and it has to add to a negative 4 to b. So the bigger number always matches the sign of this. So since it has to add to a negative, out of these two, 5's bigger, so I know it has to be the negative 1. And that would work. 1 times negative 5 is negative 5, and 1 plus negative 5 is negative 4. So then I'm going to bring down this 3, and then I'm going to have an x here and an x here. Since there's no number in front, it's just going to be a 1x and a 1x here, because x times x is x squared. And then I'm going to take my positive 1 that I found here and my negative 5. Okay, and then we're going to set each factor equal to 0. So this factor doesn't have an x, so if I set it equal to 0, there's no x to get out of that, so I could just ignore this. And then I'm going to set x plus 1 equal to 0 and x, so both of these factors. And then solve. So we get negative 1 and we get positive 5. Okay, so now let's go ahead and try it again, and let's go ahead and complete the square. Okay, so with completing the square, we want the term in the very front to be a 1. And then we want the constant on this side. So we're going to have 3x squared minus 12x. And we want this minus 15 over here. So we're going to add 15. And then when we complete the square, we want this to be a positive 1. So we're going to go ahead and divide everything by 3. Now, if 3 did not go into one of these numbers, you just have a fraction. But since it goes evenly into it, negative 12 divided by 3 is negative 4. And 15 divided by 3 is 5. Okay, so once we have the constant alone and then we have a positive 1 here, we're going to take this negative 4, we're going to divide it by 2, and then we're going to square it. And this is the number that we are going to add to both sides. Now whatever we do to one side, we want to do to the other side. So now the point is, by adding this 4 here, this is factorable. Now keep in mind, it was already factorable. So completing the square is mainly, you would use it when it's not factorable, because you're putting in a number that will make it not only factorable, but it will be a perfect square. So we're going to have 5 plus 4 is 9, and then we have to find what multiplies to 4 and adds to negative 4. Now, this will always be this number right here. When you take this b value and divide by 2, this will always work because we are completing the square to make it a perfect square. So negative 2 times negative 2 is 4, and they add to negative 4. So again, it will always be this number here. That's why it's very important if you show your work here, when you're finding this number, you can just look up and see what number goes here. So it's going to be x minus 2 times x minus 2. But instead of writing it like that, we could write it with a square. So now to get rid of that square, we're going to square root both sides. And when we put that symbol into a problem, we need to put the plus or minus. Then this square will go away because remember the index here is a 2, and 2, we can write this as 2 divided by 2 right there. We can write radicals with exponents, and then 2 divided by 2 would just leave it x minus 2. So that's why this just goes away and we just bring down the x minus 2. Now the square root of 9 is 3. And then we're going to add 2 to both sides. And then we would have 3 plus 2, which is 5. And then we would have negative 3 plus 2. So negative 3 plus 2, and that's negative 1. So again, we get the same thing we got here by factoring the original problem. We got our 5 and we got our negative 1. Lastly, we're going to do the problem one more time, and we're going to use the quadratic formula. So the quadratic formula, the problem has to equal 0. So the original problem was. So we're going to use A is 3, B is negative 12, and C is the constant, which is negative 15. So we have negative b plus or minus b squared minus 4ac all over 2a. So go ahead and simplify that. So here we have the opposite of negative 12. So negative b means what's the opposite of b? So if b is negative 12, the opposite of that is positive 12. Negative 12 times negative 12 is positive 144. Now if you're using your calculator, remember you need to use parentheses. If you don't use parentheses, it's going to give you a negative 144. This number will always be positive because it's b squared. And when you square a number, they have the same sign, so it's always a positive. Okay, then over here, we're going to enter this in as negative 4 times 3 times negative 15. And that is positive 180. 2 times 3 is 6. Okay, and then we have 144 plus 180. All over 6. Okay, we cannot do 12 divided by 6. I know it's so tempting. You have to simplify the radical. So I'm going to go ahead and make a factor tree, and I'm going to go ahead and pick 4. 4 goes into 324. I know that right away because the last 2 digits is 24, and I know 4 goes into 24, right? That's the divisibility trick. So 4 goes into 324 81 times. Okay, so to escape the radical, you need 2 of a kind. So these 2 pair up, 1 survives, these 2, 1 survives, these 2, and there would be no factors left inside the radical. So that means that if I had just done this, square root of 324, if I had just put that in my calculator, it's a perfect square. It's 18. And that's what we get here, because 2 times 3 is 6, 6 times 3 is 18. So didn't even need this, could have just put it in my calculator. So this is 18 right here. So we'd have 12 plus or minus 18 all over 6. So then we're going to do 12 plus 18. So 12 plus 18 is 30. Divided by 6 is 5. So that's one answer. And then we're going to do 12 minus 18. That's negative 6 divided by 6. Is negative 1. So again, we got 5 and negative 1, same thing we got using these methods. And then go ahead, now that we've done it all 3 different methods, ask yourself, how would you have done this one? So I would have probably, my go-to would have been to factor. And again, remember you can plug these numbers into the original problem, and that's how you would know your solution is correct.